Hi, welcome you to Remedial One YouTube channel. Today we continue to look at derivative by first principle. We have done the first lesson on this, and we are finishing it with this part 2. Please go ahead and subscribe if you haven't done so. We're giving you all the secret, the hints, and the strategy for you to pass and really pass well. Here we have a first question. From the first principle, we are going to find the derivative of 3x squared minus x. So I want us to look at this one. Because of this minus here, it can be a little bit challenging for most of our students. So that's the reason why I want us to look at this. And this question is a past question, 2019. First of all, we will say let f of x equals to 3x squared minus x. If that is the case, we have to be mindful that we are using the definition by the first principle, which is derivative of x is equals to the limit at h tending 0 f of x plus h minus f of x all on h. So here, if that is the case, that implies that our f of x plus h must be equals to, wherever we see x here, we're going to replace it with that x plus h and all squared, and then minus x plus h. You have to put in a parenthesis because the minus is affecting all of them. Then we are going to plug it into our definition. So this implies that the derivative of f of x is equals to the limit as h tending to 0 f of x, which has been getting as this. So 3 parenthesis h all squared minus, and then the formula also has minus, so minus this here, 3x squared minus x all on h. This implies that the derivative of x is equals to the limit as h approaches 0. We are going to expand this one, and then from our first video we can use the binomial expansion, which is going to be x squared plus 2xh plus h squared minus, at this point we can also remove the brackets over here, and when we remove the brackets, the h is going to be negative, and then here we are on this part, we are removing the bracket, so it's going to be negative, so it become positive all on h. We are making a headway. This implies that the first derivative of f of x is equal to limit as h approaches 0. We are distributing the 3 to over the addition here, so we're going to get 3x squared plus 6xh plus 3h squared minus x minus h minus 3x squared plus x all on h. We're about to eliminate some of them. This and this will turn into 0, this and that will turn into 0. This implies that the derivative of f of x is equals to the limit as h turn into 0. We got 6x h plus 3h squared minus h all on h. Here we see h in each side of it, so we can factor that out. This implies that the derivative of x as a limit as h tending to 0. We have h out, 6x plus 3h minus 1 all on h, and this h tending to 1, they go away, which implies that the derivative of x is equal to the limit as h tending to 0, 6x plus 3h minus 1, but h is approaching 0. So here implies that the derivative of this is equals to 6x plus 3, this is turning into 0, so 0 here, minus 1. And if that is the case, this implies that we got the derivative. By using the first principle, we got 6x minus 1 as our final answer. Alright, so we have our second question here coming from 2012 Wassce. First of all, we let f of x equals to x squared plus 3 on x. If that is the case, then our f of x plus h will be equals to, wherever we see x, we replace it with x plus h. So we replace it with x plus h. And now we are using the definition, derivative of x is equals to the limit as h tending to 0 of f of x plus h minus f of x all on h. So this implies that the derivative of f of x is equals to the limit as h tending to 0, and we are writing this one first, which we can also expand right from here, because we know the expansion of this using the binomial is going to be x squared. I hope you don't get confused. And then 2xh plus h squared. Then we write this 3 on x plus h, and minus, the minus is coming from the formula x squared plus 3 on x all on h. This implies that the derivative of f of x is equals to the limit as h tending to 0, got x squared plus 2xh plus h squared plus 3 on x plus h minus squared minus 3 divided by x all on h. Okay, let's do that. And this and that will turn into 0. That's all that we can do at the moment. So let's continue. Let's take it one by one. This implies that the derivative of f of x is equals to the limit as h tending to 0, 2xh plus h squared plus 3 on x of x plus h minus 3 all on h. So here we see the two fraction here with the two different denominators. Let's bring them closer and see the outcome. So this implies that the derivative of x is equals to the limit as h tending to 0 of 2xh plus h squared plus, so here we multiply the two denominators of and x times h here, then we cross multiply, we get 3x, and cross multiply here, get negative 3 times that will be negative 3x, and then negative 3 times h will be negative 3h. Because of the space, I'm trying to all on h. And once we do that from here, we see that this and this are the same with opposite signs, so they turn into 0. Derivative of f of x is equals to the limit as h turn into 0. We got 2xh plus h squared minus 3h, then x all divided by h. So here we see that there's h here, h here, h here, so we can factor the h, and this one is divided by h. Every whole number is over 1, so over 1. So this implies that derivative of f of x is equals to the limit as h turn into 0. We take h out, here becomes 2x plus h minus 3. Also, we have taken the h out, all on x into bracket x plus h. And this one, since we have a fraction divided by a fraction, so here becomes, we are going to multiply, it's going to turn into multiplication, and we flip it, so it's going to be 1 over h. And you see we have h divided by h, which turns into 1, so this one here will cancel that, making a headway. So now this implies that the derivative of f of x, as h is turning into 0, wherever we see h, will be equals to 2x plus 0, and then minus 3, and we got x into bracket x plus 0, which is equals to 2x minus 3 x times x. And finally, implies that the derivative of f of x is equals to 2x minus 3 all on x squared. And that is the final answer. Cool. So let's look at this one. This one has not come yet in elective mathematics, but you gotta know it. It can possibly come this year, so we have to be all around. So here we let f of x equals to root of x. If that is the case, this implies that f of x plus h is equals to, wherever we see the x, we just replace it with x plus h, and then we are using the definition. The derivative of f of x is equals to the limit as h turn into 0 of f of x plus h minus f of x all on h. So this implies that the derivative of f of x is equals to the limit as h turn into 0 root x plus h minus root x all on h. At this moment, kind of we are stuck over here, but we realize that most of the time we said that when we have a square root at the bottom, that's where we say it's not allowed, and we have to rationalize. Though here we have it at the numerator, for us to make a headway we have to rationalize. So here this becomes numerator rationalization, so we have to rationalize. And as we are rationalizing, I'm just going to take it from here because of the space. We are multiplying it by the conjugate, and the conjugate is the opposite of that. So we're going to multiply here by the conjugate, which is going to be root x plus h plus root x, and we have to do the same thing here, plus root x. This implies that derivative of f of x is equals to the limit as h turn into 0, so we multiply root x plus h minus root x brackets here, and it's multiplying to its conjugate plus that of that. Then here got h times root x plus h plus root x close it. And anytime we are multiplying here, we see that it's the same except the sign, so we take only the negative and then we square it. So this implies that derivative of f of x goes to the limit as h tending to 0. We take only the negative and we square it. Then here h into x plus the root of x. This implies that we got the derivative of f of x goes to the limit as h tending to 0. This is going to square it, then square it. And when we square this, get this, and this, get that. So this implies that we get derivative of f of x is equals to the limit as h approaches 0, x plus h minus x on h into bracket x plus h root plus root x. So here this and this goes away. So this implies that the derivative of f of x is equals to the limit as h tending to 0. We got h at the numerator and then h here, root that plus root of x. And we know that h divided by h is 1, so that goes away. So this implies that the derivative of f of x is equals to the limit as h tending to 0. So here we got 1 and then we have root x here, h is tending to 0, and then plus root x. The derivative of f of x is equals to 1 on root x plus root x here, which is equals to 1 on root x plus root x become 2 root x as a final answer. And we are done. Guys, try to also do whereby it is in the rational form. Possibly that can also come, so make sure you look at that one too. And if you do it, the answer have to be -1 on 2 root x cubed. And also try to do this one too. Possibly that one can come. We have done a big component of it, but because of the time we couldn't do all. And if you try this one too, the answer have to be alright. I'll leave in a comment if you got it right. Guys, that's all the time will permit us to do. Please go ahead and subscribe if you haven't done so, or if today is your first time here, leave us a comment and like the video. See you in the next video. Be blessed. Bye bye.